certain method that we use.
Form method.
Exactly. What's that called? The product of
Oil method.
We said form method. That's the method that we multiply. However, this is the product, which means we're multiplying a sum and difference. So we're multiplying two different factors. And we said there's something important about that. What's important? What's supposed to happen? Return cancels out. So if we do, what's going to be the answer? A. Right. Thumbs up if you got it. All right. Pass your first 5 sheets and one sheet from the row while I pass out your quiz from the other day. Thank you. Okay. So let's take a moment and let's go over what happened on your quiz. Let's check to make sure everybody's clear. Starting with, I want to say the first 3. You got any questions there?
1 and 3.
1 and 3. Here we go. So, when you factor this, what's our first thing to do?
Multiply the outside.
Outer terms to get
6.
So it'd be
6 times 1.
6 and 1. The factors have to add up to the middle term. They add up to 7. So these give us our two middle terms. We would say
6 plus 6 is
6 first.
okay. Plus 7.
6 and a 1 are the coefficients of the middle terms. Right? Group. Group. 2x.
You get x plus 1
because it doesn't have a great factor.
plus 3.
So,
2x plus 1 x plus 3.
okay. 3 and 3. Our first step is always to make sure it's in order and look for the greatest factor. What is it? 2. Okay. Now, we discussed ignoring this until the very end. Okay. So what would we get? Negative 12. That to add up to 1.
12, negative 1.
Negative 1 and 12. Negative 1 and 12. So this says the factors are different and they have to add up to the middle term. So therefore we would say
4x squared plus 12x minus 3.
it's negative.
Then you get 4x. And x plus 3 is negative 1. X plus 4x minus 1. Don't forget that.
And then on 2 there. And 2 there. There are 3 products. So we need the factors, the binomials, as well as the greatest factor. So we want to clean up your work. Those brackets. Just to show that it's running down with it. 4 and 5. Which one?
4 and
5.
5.
I've done 5. I've done 4. Here's 5. Our first step in order to see an equal sign is to do that zero product property. So we have to put it in standard form. Add 17. So 10n squared will be first. What will be the next term?
Plus 17.
Right, because we have to go down a degree. 10 to 6 gives you 60. And you probably have to play around with this a pretty good bit. 12 to 5. Yeah. That one I was going 6 to 10, 2 and 30, blah, blah, blah. For that? Hey, round factors. 10n squared, what do you want to do? Visit? This was better. Then we group and we work it out. So, what's my factor? 10. Right, just we do the opposite. Things that people made mistakes on, I think you maybe, yeah, maybe that negative 17, you didn't make it positive, and then you probably made both of these negative and messed up the rest of your problem. Some people did that. You can leave the answer like this, but you're supposed to put them in braces to show a set. So the lowest one, that's one that would go first. And then, but that's okay because I see the answers. All right, pass your books to the front. You roll. So then we're going to factor differences of squares. It's almost like what we did whenever we did the product of a sum of difference. Yesterday after the quiz, I put the perfect squares on the board for people that may have forgotten their perfect squares. But if you get to this lesson, just recognizing the perfect squares. So we factored trinomials into two binomials. We've done the leading coefficient being 1, we just factor it. We've done the ones where there's another number as a little leading coefficient where we have to multiply them and do the factor by regrouping. And then today, we're going to factor binomials that are differences of squares. So they call these the special case polynomials. So our objective is to factor binomials that are differences of squares, which is what we're saying. And we're going to use this also to solve equations using which property. How do we solve? What property says to solve it? The zero product property. All right, I'll keep saying that because they put that on the EOC one year, so it's always going to show up. So why is this important? What can we use factoring for? You see me use shape problems from time to time. I think today we're actually going to do a shape problem towards the end of class. So this is our key concept. Copy this down. This is a great thing to have in your notes. It's the property. It's what we're doing. This property is pretty easy. It has what's happening in the name. What does difference mean? It means we're subtracting squares. So if I have a squared minus b squared, I'm subtracting two things that are squared. So therefore, I can split them. I'm doing the opposite of that sum and difference. I can take a and put it in both of the factors. I can take b and put it in both of the factors, and then just make both of the signs different. That's all we're doing. Splitting up the perfect squares. So here's an example. If I had x squared minus 25, well, x, we can split it up as x and x, and then 25 is 5 and 5, and then you just split up the factors. And they're just showing you that it doesn't matter which order. That's the commutative property. We can do it again if I had t squared minus 64, but then I can do t minus 8t plus 8. Simple as that, splitting squares. So we already covered this. I said that when we did the first 5. We said, what happens if I were to factor or multiply these two together? I said, what happens to the middle term? Yeah, we said the middle term cancels out. So how does this relate to the differences of squares from what you just saw? There wasn't a middle term at the beginning. So when we factor apart, it just ended up being a sum of the difference because there was no middle term. All right, here's our first example. Call up somebody. Will, what you got? C. Products are different. Answer C. Let's try it again. This time let's use some different perfect squares. So split the squares. Chelsea. 8. 5 and 5. Did you split up the first term? And then the 6 and 6. Make the signs different. It's pretty easy, right? All right. Then, what happens if there's the greatest common factor? That's where we go next. What if I had a problem like this? Write this down. All right. What is my greatest common factor? I divide by 4. What's left?
2. Yeah, 50.
So there's still a factor. We didn't get the greatest factor.
Oh.
What else
That's
is
the
it?
greatest factor is 8.
I guess 80.
Yeah.
Yeah, we just couldn't tell because of the 200. So if I take out another 2 to go with this 4, now it's 8. Because I multiplied the greatest factor once I pulled out the other one. Okay, so 2y squared minus. So now what can we look at this? Is this a difference of squares? Yeah, because we're subtracting perfect squares. So what should be my factors? Factor that. Just split it up and change the signs. With that greatest factor on the outside. Questions? Try one. Try this. Factor. Is there a greatest factor? 5 and x. So this should be what's left over. 1 divided by 5 is 4. That's what you said. Okay. Can this be factored? Yes. So we get 5x. Okay. So that was just one of the difference with a little extra to it. All right, so we got that. So now we've done regular difference of squares. We've thrown in the greatest common factor. Let's do one that, let's see, that requires a little bit extra. Write this down. What if I had first step whenever we're getting ready to factor something? Put it in order. And put it in standard form. So we switch it. X to the 4th minus 81. So put it in from greatest to its standard form. Now, with a problem like this exponent, this 4, we can actually split it up. So I would put y squared on one side and then y squared on the other side. So not y to x. So I'd say x squared, and I'd split that up to 9. So what I did, I took the exponents and I put half of them over here and half of them over there. Because when I multiplied them together, they gave me x to the 4th, so I took them apart. So now we still have to look and see if we can factor further. You see a difference of squares anywhere. Difference means subtract. Are we subtracting perfect squares anywhere?
3.
We're subtracting perfect squares, so this needs to be factored. We have a difference of squares. So therefore this becomes, what? So I can factor this. This is adding these squares. So we're not supposed to factor the addition of squares, it's the difference of squares. So therefore nothing happens. Nothing happens without that. That's the answer.
What you put extra the line for the ground?
Because you're not supposed to factor it.
It do got subtraction is fine.
This one, we have to split it because we're subtracting perfect squares. X to the fourth is actually a perfect square. It's x squared times x squared. Perfect squares, whenever we multiply two are the same thing. So I had to split that up. And 81 was a perfect square, so I split it up. So when I got to the next step, we look for another difference of squares. This was a difference of squares, so I split that up. So I'm just splitting up things that are being subtracted.
So you can't split up the x.
Right here.
Oh, the last part.
This part. This binomial is a difference of squares because I'm subtracting two perfect squares. So therefore I factor the difference of squares. But this one, adding is not what we're looking for. We're looking for subtraction. So when we see subtraction, that's how we know it's factored. Yes, ma'am.
So you saying the answer is x squared plus 9?
X minus 3 times x plus 3 times x squared plus 9. All three of those are the factors. Okay? Let's find the other one. Let's try this. Okay. Actually, just kidding. Just kidding. That's the only one like that on page. But I have one over here. There we go. We're subtracting perfect squares. You want to try it or you want to do it again? Try. Try. Okay. Leo, tell me what's my first step?
You split it to 16.
Y squared.
Y squared parentheses. 4.
It's 4, and then y squared. So minus 4.
And then you split up to negative that one.
Down.
The process of elimination is D.
This.
I get why you asked them why too, because you got the most problem too, why? That'd be square, you know, problem too.
You're working with the answer choices back to the answer.
Yeah.
No, I'm just like, I can see why you did it.
Business.
Yeah,
Does
but
it,
I got D on the first.
does it matter when you put y squared plus 45? Does it matter?
It does. Because these are three different things that multiply to give you this.
On the other one, you put it in, it's the last one, this one, the first.
Oh, like first to last. The commutative property. The commutative says you can change the order, so it's the commutative property of multiplication. So it doesn't matter which one goes first.
So the only time you have three answers is when you don't have a number for a variable.
The exponent, like if it's to the fourth power or to some other power, then that's when you split. That's when it might be more than one factor. You want to see another one of those? You could. One more. Okay. I got one this time. Actually. So you're memorizing that, and that's what you're doing. So you see how to jump from there.
Is there any way that we adding and subtracting?
That's what Morgan was asking, which one should go first? It doesn't matter which factor goes first because of the community problem. Okay. Ready? B squared minus 25. Oops. this is the one that switches to 5 and 5 because we factor this. We take the 25 apart. But we don't do anything with this one because we don't factor the additional squares. We don't factor the difference of squares. Okay, so when we subtract this, we do. All right, I'm almost done. I got a couple more, one more or two more objectives to go. Let's see what else I got. Let's see what else I got. Try that. Try that. There's a GCF in there. Show you work.
Where's that for?
Oh, your fault?
Do it together. Let's go. What's left?
Minus 4.
Okay.
And then right there, you can
Where you down?
X minus 4. Plus 2. And then plus 2.
Minus 1.
Oh,
Okay,
two.
that way I know.
2 is not a perfect square.
Oh, yeah.
2 is not a perfect square.
Yeah, got it.
You can't. So the answer is, so we can only take them apart if they are perfect squares. Difference of
Perfect.
perfect squares.
Like that. You say that. You say that we do the homework.
Sorry, with pardon the interruption, I need to see Amber Lucas for just 1 minute.
Okay,
Thank you.
try that. I think this one maybe.
I don't know.
Let's do it by 2.
If you take out the greatest factor, it goes to the side. Kurt, what's my GCF? 2. What about the variables? Y. Squared. What would be the
2y to y squared minus 16.
Then break it down. Y plus 4.
That's
Y
GCF,
plus 4.
remember?
Oh, yeah, 4.
Y minus 4.
It's 4.
Then Y plus 4.
There we go.
And then break Y minus 4 down. No, hold on, wait a minute.
The Y is not.
Yeah.
You gonna break that y?
Oh, you bring down that 2y.
Because we can't factor.
How many we bring down
That was
that?
our-
What we distribute?
We can only take it apart if it's a binomial or trinomial or something. This is just a monomial. We don't factor the monomials. It's just one term. We don't need to factor one term.
I was just asking if we bring it down.
Yeah.
That's gonna be part of it.
Because it's part of the answer. Just bring the GCF down. Something like that.
It's easy.
I'll show you set. Okay, hold on. Alright, here's my closeout, a little real world situation. Well, not my closeout, but real world. Take a moment to read that. Read that silently. Yes, ma'am. That's exactly what we need to do. There's no question here. They just started out with the situation. They said he knows his area of this shape. He doesn't know the size, but he knows that one is more, one is less. This expresses the situation that's going on. So normally the formula of a rectangle would be A equals length times width. We know A is 80, and we know the length and width of this. So our question is, write a quadratic equation for the area using the information given. So normally we would say, what was the area? 80.
X squared minus X minus 2.
And we're ready for multiply. Right. So, I put the sides together, I multiply length times width, because that was the product of the same difference. So it's like, what are the length and what are the width? How do I solve anything? What was that problem?
Zero product, zero product.
Move them to the same side. We can think of this as if it was this. Couldn't we?
Yeah.
So what would I do?
You subtract
80. What's negative 64 and negative 80?
Negative on the root 44. Then you gotta move that root 44 back up to the plus. You break it apart.
Break it for factor.
Oh, yeah.
So what's 12? It's minus 12.
Oh, wait, we haven't finished yet.
Now, here's the thing about this. We got two answers. We have an answer that's negative, we have an answer that's positive. X could either be 12 or negative 12. We plugged in 12. 12 minus 8 gives us 4, and 12 plus 8 gives us 1. So 20 times 8 is 80. Okay, so we know that answer works. But what if I plugged in the negative 12? What's negative 12 minus 8?
Negative 20.
Can a side, a length, a measurement ever be negative? No. So therefore, that's called an extraneous solution. We don't need that solution. So our answer is 12. What are the length, what are the width? 4 and 20 are our answers. Got it? Here's the last question of the day. It's a challenge question. Homework's on the board. I want you to work it. 4 terms. 4 terms. We need the group. Factor by regrouping. There is a GCF. You want to take that out first, or you want to regroup first?
Take it out first.
So it is 5.
No,
And every one of them. No, 15. 45.
Oh, it is false. Calculate that. That's okay. Now what? Ignore the 5 until last.
Yep.
Okay. Do this. So x squared comes out. What's left?
X plus 5.
GCF. Not GCF, but what we take out in the next one.
Oh, wait, you already done the regrouping?
Look it down. It's so like,
So the X, the X5, the X2 comes out.
what's left?
X plus X.
So then we have
X squared minus 9, X plus 5.
Are we done?
No. Yes. No.
No.
Yeah, no.
It's five.
No. X minus 3, X plus 3, X plus 5.
Is that the final answer?
No.
No.
5.
5. You gotta remember that 5. See, I do that on purpose because I don't want these brackets to just confuse y'all. I can bring the brackets down with it so you know the brackets show that we're multiplying 5. Homework. Page 115. I want you to start. I'm done early. Covered everything. Anybody got any questions about that? You saw everything you need to see. Start your homework, ask questions, work with a partner. Let's see what I can short. It should be easy because I'm gonna split most of them. So I think, you said you all got somewhere. Now,
Can we skip the fractions there as well?
you just split up the numerator.